Hi everybody! It is my honor to present our work investigating search among physical and virtual objects under different lighting conditions here in the ISMAR 2022 conference. I am You-Jin Kim, a PhD student and a member of Four Eyes Lab in the University of California, Santa Barbara. I had an honor to work with Radha Kumaran, Ehsan Sayyad, and Milner, Tom Bullock, Barry Giesbrecht, and Tobias Höllerer, fantastic researchers here in the UC Santa Barbara on this project. We present one of the first experiments studying human search behavior in a wide area outdoor, augmented environment. Participants explored the area as you can see in this image to find and classify all the gems in the space based on the appearance of the gem. In half of their trials, participants were asked to complete audio tasks on top of search tasks. From the early days of augmented reality, there were many technical challenges such as tracking and rendering when used in a wide area outdoor space. However, these works you see here paved the way for our experiment. In some ways, we were truly encouraged by these work, as conducting outdoor study can be challenging. Here we see early works such as ArchiGuide project, AR Quakes, and much more. Our first goal was to test the impact of different lighting conditions on user behavior and subjective reports on AR experience. Mass adaptation of AR in the future will present AR usage of all lighting conditions, and during our initial pilot testing, using HoloLens 2 headsets, it became apparent that A. The lighting situation for outdoor study must be constrained by the lighting conditions that did not consist of direct sunlight. B. That user perception of augmented world likely would differ quite a bit from ambient natural light and nighttime settings. As such, lighting condition was included as a quasi-independent variant in our study design. Our second goal was to assess the influence of physical and virtual objects in AR users' behavior while during wide area search and classification tasks. AR user must navigate around both physical and virtual objects in the environment, so it is important that differences in how they interact with both types of objects are well characterized and understood. Our third goal was to assess the impact of cognitive load on user performance. AR system will be used in individuals while under various settings. User may navigate around street while using ARQ navigational guidance while talking on the phone, so it is important to understand how multitasking impacts attention to the AR environment. This is a short clip recorded from our study. Participants navigating this augmented environment at Kirby Crossing, one of our campus locations, using Microsoft's HoloLens 2 headset to search virtual gem in the scene. Participant performance in the task and search behavior was recorded. And what you see right now is the playback software we made to replay and analyze user behavior.
Alpha.
Here you see footage capture from a headset directly using MR capture software, user completing search
Alpha.
task in the ambient natural light setting.
Delta. Echo. Bravo. Delta. Charlie. Echo. Alpha.
What you see here right now is a projected virtual
Bravo.
gem is being occluded by a physical object.
Echo. Alpha.
The experiment was conducted outdoor on the UC Santa Barbara campus in an area approximately the size of 3 basketball courts. Participants were allowed to walk on all area in the space, but discouraged from walking on the green grassy area. Here we see physical objects we had to install precisely aligning with the word anchoring of the headset. This was quite a task. We spent many nights installing these objects. Look carefully here as virtual object is layered on top of physical ones to complete the scene. The space was augmented with number of physical objects, evoking a leisure-oriented courtyard scene with digital twins, 3D replica models of the physical objects. The purpose of introducing the digital twins was to examine the difference between interactions with gems hidden behind virtual and physical objects. There were also a number of virtual objects in the space that did not have identical physical versions. User performed 3 tasks, the first 2 during experiment, and the third after the experiment. The gem search task required participants to find and classify gems found in the area into one of the 4 categories based on orientation and texture. The task was complete when participants felt they had found all gems in the space, and thus the duration varied for each participant and each trial. We measured accuracy in gem search performance along with behavioral metrics such as distance traveled, head rotation, and total time. Lighting was a between-subject variable, which each participant experienced only one treatment: ambient natural light, which was usually an hour before sunset, and the artificially lit night light condition, which was an hour after sunset. We also introduced a dual audio task to manipulate participants' cognitive load, which was performed in conjunction with the gem search task in the half of their trials. 24 gems were placed in the area, evenly divided into 3 groups: those that were not occluded by any objects, those occluded by physical objects, and those occluded by virtual objects. In half the trials, participants performed a simultaneous audio response task where they listened to a stream of words, played in the randomized order, and responded to each occurrence of their assigned target word. We measured response accuracy and response time as dependent variable, with light being quasi-independent variable. After the experiment, participants were tested on their memories of objects that may have been present in the space. They answer a multiple-choice object recall test, categorizing objects into one of 4 classes: absent, present as a real object only, present as both real and virtual objects, and present as a virtual object only. To summarize our result, first, participants reported lower comfort in natural light when compared to at night, with trend of more fatigue in natural light. Participants had an impaired recall of real objects in the environment compared to virtual objects. And they also discovered fewer gems hidden behind real objects than behind virtual ones. This suggests reduced attention to and awareness of the physical environment, which could be either due to all search targets being virtual or due to the novelty effect of augmented reality. Further, dual tasking modifies search behavior with reduced head rotation when performing both gem search and audio tasks simultaneously. The findings indicate that wide area AR tests are less comfortable in natural light than at night, as supported by participants' reports of lower comfort in natural light as well as trend to more fatigue. There was also significantly reduced attention to physical environment compared to the virtual object, as suggested by the significantly less accurate recall of physical objects in the scene compared to the virtual ones. This was also supported by a significantly higher search performance with gems hidden behind virtual objects than behind physical ones. Dual tasking implied a more restricted user search strategy with significantly lower head rotation when performing the simultaneous audio task. In conclusion, we present one of the first controlled user study on search behavior in wide area augmented reality, with 48 participants performing search tasks in an outdoor environment that is approximately the size of 3 basketball courts. Although the community is well aware of the challenges in viewing virtual content in natural light due to accommodation of vergence conflict and the ghost-like appearance of annotation viewed through optical see-through display in natural light. We are the first to demonstrate that this has an impact on self-reported comfort. We also discuss reduced attention to the real environment when performing wide area AR tasks, which could have important implications for the safety and effectiveness of AR applications designed to be used outdoor. This affects needs further investigation, such as by introducing physical search targets in addition to virtual ones. We have developed a system that enables user studies in outdoor wide area environment, which could be used for future comparative experiments on user interface in outdoor augmented environments. Of immediate interest to the authors are analysis of the impact of visual clutter in terms of AR annotations and a comparison of guiding interfaces in search tasks. The project was truly a joy for me to participate in, working with friends and researchers. We hope this work is beneficial to our AR community, and thank you so much for listening.